Hello, everybody. We're going to talk more about parabolas today and graphs of quadratic equations. So, in this lesson, we're going to look at graphs of equations as forms y equals ax squared plus bx plus c, where a is not equal to 0. These are otherwise known as quadratic equations. So, the graph of the equation is called a parabola and is U-shaped. Okay, so they're all going to look either like this or they're going to look like this. Okay, one of those two types of things. And they can be wider, or they can be narrower. Doesn't really matter. If the leading coefficient is positive, so the leading coefficient is the a, it's the number in front of the x squared, then it's open up. Okay, if that leading coefficient is negative, it's going to be open down. The axis of symmetry. So these are symmetric. Okay, there will be a line, imaginary line. I drew that terribly. It'll kind of go right down the middle of those things, okay? That's called the axis of symmetry. And it's the symmetry line for the parabola, okay? You can find it using this equation. X equals negative b over 2a. Okay. That's a formula you're going to want to know. That gives you the x coordinate of the axis of symmetry. Okay, so how do you graph a quadratic equation? If a is positive, the u is open up. If a is negative, the u is open down. I would write that down at the very beginning of the problem. I can't tell you how many times I've had students that they have a negative leading coefficient, they draw the parabola, and they get it right side up. Okay? That should tell you right away, something's wrong, this is messed up. The x-coordinate of the vertex is negative b over 2a. The vertex of the parabola is located at negative b over 2a y. And then I should really have a step 4 on here that says pick 2 points on either side of the axis of symmetry and graph them. So a line, you need to have 2 points to graph a line. A parabola, you really need to have 5. Okay, you're going to have the vertex always. That's going to be the most important point. Then you're going to have 2 points on the left and 2 points on the right. Now, the nice part is, since it's symmetric, you can cheat. Okay, you really like to graph 3 because you're gonna get 2 points for free, and you'll see that here when we do this problem right here. Sketch the graph of y equals negative x squared minus 2x plus 8. So the very first thing we want to do is calculate the axis of symmetry. That's going to be negative b over 2a. I suggest you write the formula down every time. My b is going to be negative 2, so that means it's going to be positive 2 over 2 times negative 1. So that's 2 over negative 2, which is negative 1. That's my axis of symmetry. So I'm going to go get that. And let's make it nice green color. And that's going to be at negative 1, so it's going to be right here. Okay, there's my axis of symmetry right there. Next, I'm going to make a table, and the first thing going to that table is my axis of symmetry. That's going to let me find the vertex. So I'm going to plug it negative 1 into this equation. So I'm going to get negative 1 squared minus 2 times negative 1 plus 8. So negative 1 squared is 1, but it's negative 1. Negative times negative is a positive. So this ends up being 9. Okay, so the vertex is at negative 1, 9. That's going to be right there. Now, I know this thing is open down, fortunately, because if it's open up, it's going off my graph, right? So this thing is open down. I would probably write that here somewhere, okay, because of that right there. That's my leading coefficient. Okay, now I'm going to pick some points. So you don't want to get too far away from the axis of symmetry because these things tend to either shrink or grow very fast. And whenever I can, I like to use a 0 because 0 is very friendly. I know that if I plug 0 into this, this all becomes 0 and I just get 8. So 0, 8 is going to be on the graph. Now, I told you that when you kind of buy one, get one with this, since it's symmetric. So since this point is on here, I'm going to have another one right here. So -2 is also going to give me 8, and I don't even have to calculate that. Okay, now if I calculate 1, that's a pretty easy thing to count. That's going to be -1, because 1 squared is 1, and then that makes it negative. -2 times 1 is -2, plus 8, that's going to be 5. So 1, 5. 1, 2, 3, 4, 5 is going to be on the graph. And like I said, I'm going to get another point for free right there because it's symmetric. So that'd be -3 is also going to be 5. Now, if I wanted to make this a little accurate, since I'm way up here and I got lots of room down here, I might do one other point. I might do a 2. That'd be -4. -2 times 2 would also be 4. Plus 8. That's going to come out to be 0. Now, I like to have x-intercepts whenever I can. Okay, and I'm 1, 2, 3 to the right. So if I go 1, 2, 3 to the left, I'm also going to get 0. That's at what, -4? All right, that's really all I need. I'm just going to come over here and I'm going to do this. And there's my graph. Okay. So, there we go. Now, the only thing that's kind of hard about this, like I said, you buy one, you get one here. Sometimes when the axis of symmetry is not in a nice place, like maybe it's at 1/4. Okay, well, it's hard to symmetrically graph them. You might choose 0, you might choose 1. Those are going to be different places. 1 and 2 are going to be different places. It's got to be the same exact distance from the axis of symmetry on both sides. Okay, here's what I want you to do is I want you to pause the video, give this one a try, and then jump back on and see how you did. Okay, so I'm going to go with -b over 2a here. So that's going to be -4. That's going to be +4 over 2 times 1 is 2. So the axis of symmetry is going to be at 2. So I'm going to go over here. There's 2. There's my axis of symmetry. So now I'm going to go ahead and make my table. Uh-oh. That's all right, I plug in 2. So 2 squared -4 times 2 minus 5. So that's going to be 4 minus 8 minus 5. It's going to be -9. Okay, so 2 -9 is going to be right there. Now this thing is also open up, which is fortunate again. So that's positive. Okay, and then we'll go back and we'll pick, again, 0 is my friend most of the time. So if I plug in 0, I get 0 minus 5. So 1, 2, 3, 4, 5. And to be symmetric, that's also going to give me 5 at 4, or -5 at 4. Okay, 1 is an easy one to calculate. That'd be 1 squared minus 4 times 1 minus 5. That's going to be 1 minus 4 is -3, -8. 1 -8 is going to be right here. Means I'm also going to be right there at 3 -8. And, I'd really like to have my x-intercepts if I can get them. I have a feeling that if I choose 4, I bet I get there. So that'd be 4 squared would be 16 minus 4 times 4. Oops, that's not going to work. 4 squared is 16 minus 4 times 4 is -16 minus 5. Oops. let's start over. Oh, wait. I already had that one. Right there, that's why it's repeating. Let's try 5. That's why that wasn't going to work. Okay. So 5 squared would be 25. Minus 4 times 5 would be 20. Minus 5, that's going to end up being 0. 5, 0. 1, 2, 3, 4, 5. And I went 3 this way, so I go 3 this way. That's a negative 1. I'm going to get 0 there. And so I've got a good parabola right here. It's going to look like that. Okay, so hopefully that's what you got. Okay, the area of a parabolic region can be found using the formula area equals 2/3 the base times the height, where the base is the distance from like here to here of my region, and the height is going to be from the base to the vertex, okay? So here we have the Anasazi village of Pueblo Bonito. It's shaped like a parabola. You can kind of see the parabola right here. Okay, here's the base that goes across here. The height would be like right there. Okay, so I'm going to get out my formula. Area is going to be 2/3 the base times the height. Okay, and I forgot to put the base on here. So the base of this is, I believe, 500 feet. And the height of this is 300 feet. Okay, so I'm going to go ahead and plug this into my equation. So the area then is going to be 2/3 of 500 times 300. So again, I get out my handy dandy TI-84 plus C Silver Edition graphic calculator. And I go 500 times 300 times 2 divided by 3. And I get 100,000. And that's in square feet. Okay. And we're done. Okay, so I got a few problems here for you to work on. Enjoy those. I'll see you guys later.